Hi class, welcome to 5.3. Today we are going to talk about very important theorem in calculus, which we call as the fundamental theorem in calculus. And we are going to also study about what it means. And I'm going to explain to you with the first appetizer questions. So before I'm going to explain fundamental theorem of the calculus, let's review the relationship between what derivative means. So let's try to find the speed of driving to Skyline College and how long usually take to come to school. So I just put one example of myself. For me, it took about half an hour, which is 30 minutes, to come to 20 miles. Okay, then 20 miles takes about half an hour. So if I connect this one, and you see that this is going to time, and then this is going to be distance. Therefore, from here, my slope is going to be the rate. So let's try to find the slope. In order to find the slope, this one minus 0 and this one minus 0. So I get 20 over 1 over 2, which is 40. The unit will be miles per hour. So I found the slope. This is going to be 40 miles per hour. And as you see that everywhere is going to be 40. So I'm going to take a first derivative and then put it into the relationship t versus v. So this one was an original function, and this is going to be our first derivative function. So as you see, our slope function is everywhere 40, and it's going to be a straight line. So let's try to think about this one. If you got this part very good, now I'm going to explain to you from how long does this person drove from 15 minutes to 30 minutes. How long did I drive between here? That means if I have a relationship time to velocity, it's going to be under the graph from 15 minutes to 30 minutes. The area represents the total distance traveled. So let's try to find the area of this orange box, which is what is the base size. That was a total half an hour. So this will be 15 minutes as a 1 over 4. The base is 1 over 4 times the height will be 40. So if you multiply, you get 10. What does that mean? Total distance traveled from 15 to 30 is a total 10 miles. Okay. Now I want you to see that how do we approach this one? We are approached by multiplying base times height. So base times the height, and then all those rectangles we added from A to B. Now look at here, the other part that if I'm just using the original function, then how am I going to find what was the distance to travel? You have to see very carefully. Total 30 minutes later, I traveled 20 miles. So 30 minutes, travel 20 miles. But they want to see that from not 0 to 30 minutes. They want to see 15 minutes to 30 minutes. So if I plug in 15 minutes, which is going to be 1 over 4, that will be half of this number, right? So here it's going to be 1 over 4 and then 10 because I'm divided by 2. Then from at 10 minutes, it says that already traveled 10 miles. What can I say then? Then, not 10 minutes, it's 15 minutes, right? Then rest of the 15 minutes will be 20 minus 10. So it's going to be distance 10 miles traveled. I want you to see the relationship. This one is the original function. This is the first derivative function. But here, make you a little bit confusing, right? And confused here. Because this is the actually derivative function. And then when we use the big F, that is the original function. So if you take a derivative, then it becomes this. That is the same as in this case, f function. So I want you to see that base times height. If just try to get the idea here, and then all the area of the function is same as your original function. Plug into your b value, subtract original function of minus a value, which means earlier when I plugged in, I got 20 miles minus 10 miles in order to get that 10 miles. So I want you to see the relationship. This is going to your original function. That's your first derivative function. Also, how we write it? Antiderivative since f is my original function, antiderivative we say as big F. Okay. So now let me tell you what fundamental theorem of calculus is. Fundamental theorem of calculus is actually developed in 17th century. Before this one, actually, as you saw that there was only study about the derivative, and then there's another field of study about the area. So one field just to use the derivative study like what we learned from chapter 1 through 4. And then another mathematicians are studying about the area just using the Riemann sums. And the mentor of Isaac Newton, and his name is Isaac too. Last name I do not remember, but he is the person who found out, oh my God, there's a relationship between integral and derivative. And actually, if you take a derivative of your original function that we call as slope function, then there's a relationship that if you take an antiderivative, it becomes the integral, and which represents the area. So what I try to say here is this study was so different from this study, and the derivative study is different from area studies. And then finally, why they say fundamental theorem of calculus, and then they saw there's a relationship, then they become an opposite operation, and there was a huge fact and the fascinating fact for whole world, I guess. So that's why it's very important for us, and I hope that you remember fundamental theorem of calculus. We usually write it as the TC, fundamental theorem of calculus, and you will hear that in calculus 2 as well. Okay. Okay, so our second appetizer is about finding the unit here. So as I said, units are very important in calculus. Also, it gives us a lot of a hint. So just carefully in here, what will be the unit? So here says big F prime. That means your original function will be f function, and then big F function. And if you take a derivative, that becomes a little f function. Input is going to the time. Then little f function. So you can say this is the original function. And then if you take a derivative, that's going to be this, which is the same as just writing this way. Then from here, this is going to be velocity in miles per hour. So your function f with t is miles per hour. Then what is the unit of integral a to b, ft dt? So as we talked, this has a unit miles per hour. Then what is the unit of this one? Because we are going to multiply this times this in order to find the area. So this unit times that will be unit as an hour, and then that means just that means area, right? So from here, this cancel out. So my unit will be miles, which when we have original function as a miles per hour, if you take antiderivative, that will be miles as a distance. Then next one, how about big FB minus big FA? So little f was miles per hour. Then if you take the antiderivative, that will be function f. That has to be miles, because you are taking derivative respect to hours. So this unit also is miles, representing as a total distance. So don't forget this integral notation, and then fundamental theorem of the right side from big FB minus big FA is representing exactly same part, same thing. Okay. So now let's look at positivities. You can pause it and then you can try. Actually, I thought that you will be able to understand if you see what is the original function, what is the derivative function. So you can try it, or you can do it together with me right now. So here, and always look at the unit. F with T represents a bacteria population, which is 5 million at a time T equal to 0. So some information I'm going to keep writing down. So original function is a big F function, and then when time is the year that they start researching, the bacteria amount is 1 million. It's like a COVID time, right? It's a good kind of a question here. So after T hours, so I guess the T is hour, The population is growing at an instantaneous rate of 2 to the t million bacteria per hour. The unit is very important. As soon as you see it, do you feel that this is going to be the derivative function? And then the unit is bacteria per hour. How much is growing is 2 to the t amount is growing. Then estimate the total increase in bacteria population during the first hour. So which first 1 hour, how much is going to be total? So what we really want to try in this question will be, there's a 5 million people starting, and then the first 1 year, how much is total population of bacteria increase? That amount will be, that's what we want to show. So if I want to see this one is rate. We are not looking for the rate. We are looking for the bacteria population. So first 1 year, what will be the bacteria population? If you look at this one, they're basically asking about f over 1 minus f over 0. Right? So from here, what does that mean? We learned that using fundamental theorem of the calculus. Fundamental theorem of the calculus. That is integral from f over t and dt. So f over t, what would that be? That's going to be derivative function of the original. So I can see that from 0 to 1 year. First 1 year I want to see. But what is the derivative? 2 to the t dt here. So this part, we haven't learned that one yet. So you need to just punch into the calculator. Then I think that number is about 1.4. Yeah, then this number is about 1.44. So from here, what I can say is the population was 5 million. And then during the 1 year, how much population increase is 1.44 million more. That total population of the first year of that of the bacteria will be 6.44 million. Did I say first 1 year or first 1 hour? So what we are talking about first 1 hour, and sorry if I keep saying the year. Okay, so I want you to see how we utilizing it, and then is we can find some population. Okay, let's look at our main dish. So main dish, we are going to understand one more time how we can compute this integral from 1 to 3, and we usually call it as a definite integral. If you see the interval from 1 to 3, then it's blocked here so that we can find the area clearly, so we call it definite integral. So what does this mean? Integral means find the area under 2x. So let's graph 2x. This is 2x, and then I like to find the area under from 1 to 3. So that's what we want to find. So as you see from the function, we can actually count this one. Do you see? Oh, this one shouldn't be right. So let's count it carefully. 1, 2, 3, 4, 5, 6, and then do you see that will be 7 and 8? So the area under from 1 to 3 is going to be 8. Of course, you can do riemann sum too, but now I'm going to use a fundamental theorem of calculus. So integral from 1 to 3, 2x dx. What does that mean? 2x is my derivative function. Then I want you to find what will be the original function. What will be the original function here? So guess. 2x, I usually guess like x squared, and then, if you take a derivative, I get 2x. So for me, I usually take derivative. Antiderivative is a little bit difficult for me, so I just guess it, and then x squared, take a derivative, and then guess those numbers. X squared is going to be my original function. Then what did they say? It's going to be fb minus fa, but my f function is x squared. So by plugging fb is going to be 3 squared minus, that's going to be 1 squared. I get exactly 8, which is same thing. So graphically, I explain. Also, using algebraically, we will say just using fundamental of calculus, you can find the area under the curve and still get the same answer. So I want to try in class activities and then compare the answer with me. Hope that you enjoyed the in-class activity 2. So did you notice that my x is time and y is velocity? So if I'm computing the distance, how much is traveled, basically they're asking, can you see the area under the curve? And can you compare between car 1 and car 2? So if you look at A, which car is ahead after 1 minute? So at 1 minute right here, which car has a bigger area? Car 1 has a bigger area than car 2, that this car 1 is ahead of car 2. Then which car is ahead after 2 minutes? After 2 minutes. Oh, this one is going to be a little bit tricky because at 2 minutes, basically you need to count all those rectangles and compare. So you can do this one and then you can do this one. But what you can do is you can also compare the area. You see that these are sharing, right? Because of which now the car is ahead after 2 minutes. That means you want to find the area from 0 to 2. So of course you can compare these two areas. However, since it's not easy to do so, this one shares. And as you see, car 1 has this much area differences versus car 2 has this much. And as you see, which one is bigger? This area is bigger than the other one. Comes from car 1, that you can conclude that car 2 actually travel longer distance at 2 seconds. So if you put this piece in here, probably it's about this much, and then as you see, car 2 is still bigger as an area compared to car 1. Therefore, this will be car 2. Okay, so I hope that you understand what fundamental theorem of calculus is. And if not, just look at my dessert part again and then I will explain to you. So dessert says find the area under the graph from 0 to 4. Then we can also use the integral notation. So we can do from 0 to 4 and then we can try 2 to 4. So let's graph a little bit. So this one, since 8x is going to be really sharp slope, that I'm going to just make it a little bit, this one as an 8. Then that's going to be 16, and then 24, and 32. So I made it each height as 8, so 8, 16, and then 24, and 32. So I see that 8x graph is going to look like this way, and basically they're asking find the area under. So if I want to write this one as integral notation, would be find the area from 0 to 4 by 8x dx, because I want to find the area under the curve. Then first let's do it our geometry way, finding the area using a triangle. So this will be 4 and then this will be 32. So 4 times 32 divided by 2 as a triangle, then that gives me 64. So I got the area, it's a 64. Then how we are going to compute in using integral by fundamental theorem of calculus, telling me that this is going to be taking antiderivative. So guess 8x, what will be your guess? For me, at least I can guess it came from x squared. So I'm going to write it down. And then take a derivative of x squared. What do you get? You get 2x. However, I had an 8x. That means, I had a 4 in front because then I'm going to have 8x. So my antiderivative is 4x squared, but from 0 to 4. So I can write it 4 squared minus 4, 0 squared, basically I did FV minus FA. That's what fundamental theorem of calculus says, how we compute. This will give me 64. Oh, that's it. Same answer. Yeah. Right? Okay. Then let's look at B here. So instead of from 0 to 4, this time I want to compute 2 to 4. We will compute 2 to 4. Then that meant 2 to 4. So what they're saying is, I already found 64, right, class? Oh, let's put in the integral notation. Sorry, I'm rushing. So integral notation will be, I want to find the area of function 8x from 2 to 4. That means I'm going to take the antiderivative of 8x, which came from 4x squared. How do I know? Take a derivative. Okay, then you get the 8x. So plug in 4x squared. Now I'm going to use some fancy notation from 2 to 4. Okay, integral, after you take antiderivative, your antiderivative notation here from 2 to 4. Get familiar, you will see some homework there too. So now all I need to do is plug in. So if I plug in, that is going to be 64 again minus 16. So what do we have? That is going to be 48. Okay. Can you double check if I add it? That is going to be 4, 5, 6. Yeah. So I get 48 as area. Then let's come back. How do we compute this one in geometry? Wait. So we already found 64. And then this is going to be easier than just counting all those this one. So if you look at this one, do you see? You have to be careful again because my height is not 1 anymore. Base is 2. And height is going to be 16. Divide by 2 as a triangle. So I get 16 as area. This is a 16. So 64 minus 16, that's going to be definitely give me 48. Okay, so that's how we are going to use a fundamental theorem of calculus to compute the area from A to B of the definite integral, and definite integral. So now we have a last question of in-class activities, and I want you to try this question. Okay, class, let's look at the answer together. So 2x plus 1, I graphed it, and then just by counting the rectangle, I found the area. I just counted. So this one was a 6, and then I know that this one will be 6. Then the bottom has 8, so 14. Then if I want to write this as an integral notation from 0 to 4, given 1, hope that you guys can find the integral okay. For me, I take derivative, I just guess. 2x comes from x squared, 1 comes from x, and then I check by taking derivative from 0 to 4 using fundamental theorem of calculus. Subtract each other, and I got the area of 0 to 4, this trapezoid, as a 20. Then from 2 to 4 on the figure, this is 6, so I subtract, so I got 14. Using the integral notation, take the antiderivative 2 to 4 and subtract those two functions, I got 14. Hope that you got the same answer. Okay, I forgot there's actually another in-class activities, so I want to actually explain one and then gonna do another in-class activities, so bear with me 3 more minutes. Okay, promise, this is the last question of the dessert. So now you see the relationship. F function came from big F function integral, derivative. Then when I look at this one, this is my big original function. So if I want to find write the integral, then you need to take a derivative. If I take a derivative, that will be 4t minus 3, 4t minus 3, and that is f function. And how are we going to write this form? So careful, now we have a small f, integral from 1 to 3, and f function as a 4t minus 3. And don't forget, you have to indicate that what is your integral respect to. So in order to find this one, you can do either way. Some of you guys can take the antiderivative, but luckily they gave us our antiderivative. So for in the future, you are not gonna have this one, so that you have to induce what will be your antiderivative, which will be 2t squared minus 3t, something like that. So once you do a lot, you will see automatically. Then it's going to be 2t squared minus 3t. And they say use a fundamental theorem of calculus from 1 to 3. So see that this is my f function and this is a big F function. The relationship is the derivative. So let's compute. Now let's plug in 3 here. 2 times 3 squared minus 3 times 3. I like to use lots of parentheses. and minus 2 times 1 square minus 3 times 1. I usually skip all those work. And here I get 18 minus 9 minus parentheses 2 minus 3. Therefore, I get 9 minus 1 total 10. Hopefully I didn't make a mistake. How do you know this is the correct answer? Well, you can actually find the area of using that too, right? The area using that. Okay, then now I want you to do in-class activities. This time f of t is natural t. So I want you to pause it and then try. Pause and try. So I'm going to just continue. Those who want to watch me. I want to find the integral. I want to find the f function. This is big F. So if I take a derivative, that will get me 1 over x. So, find the integral from 1 to 4 of 1 over x function of dx. Oh, we did something similar before too, right? That is, what does that mean? Where does this one come from? Their antiderivative is natural log of t. How do I know? Take a derivative, natural log of t, do you get 1 over t? I should use the t, right? Not x. From where? 1 to 4, which you need to put natural log 4 minus natural log 1. And do you know that natural log 1 is actually 0? So your answer is natural log 4. I get 1.386. So that's the area. What does that mean? If you graph this one from 1 to 4, this area is 1.386. Okay, so this is it about the fundamental theorem of the calculus. And you don't feel that anything special, because I kind of mentioned previously a couple of times, so that you don't seem like this is totally new. But hope that helps you to understand a little bit better and faster. And then I will meet you next section. Good job, everybody.